do that. Yeah, okay. Says I'm recording. All right, so I think I'm recording now. So let's go ahead with our Python basics. Now, students, we've been as we've been going through the course, we've done a lot of flow charts. We've done some pseudocode, and in every case, I've tried to show you some Python. So I'm hoping that the Python, as we do it, it doesn't seem too strange. Also today, I'm hoping that we can do a little bit more Python as we go. So let's have a look at this. Maybe you've seen something like this before. This is actually quite important, the way this works in Python. How it works is you use a while statement with a condition. Now the brackets there are optional, but the colon is not. And when you put the colon in, then any lines that are indented, exactly one indent. Oh, sorry, should go back. One indent, they are part of that while statement. So what that means is, as long as this condition is true, these instructions will keep on being executed, and they'll be executed in the order that they appear inside here. So first instruction 1 will be executed, then instruction 2 will be executed, then the condition will be tested again. If the condition is still true, then instruction 1 will be executed, then instruction 2, then we'll test the condition again. As long as that condition is true, then these things keep executing. Now the one at the bottom is meant to show that this only happens after the while statement is complete, and that'll happen when that condition somehow is no longer true. Now in the last lab that we had, some people added at the end of their while statement, they put an else. You can put an else statement in the while. It's not really required, though, in most circumstances, because if what you're going to do is going to happen when the condition is no longer true, well, that's everything after the while. The only time that you would need to have an else as part of the while is if you were going to do a break out of the while if some condition were true. So if you had an if statement inside the while loop, and then you use a break. I'm not going to show you that now unless people ask me afterwards, because it's not really part of our instruction, and I don't want to confuse people. But just to let you know that here's a fairly simple while statement. There's some other things that we can do to make it a little bit more powerful, I suppose. I hope that this looks familiar to you now. So here's a flow chart. You can see a condition down here, and the condition is indicated by a diamond shape. And if that condition is, in this case, we're saying that so this would be while this condition is not true. That's the way the way that you would write this while loop. You'd say while this condition is not true, because we see the no arrow going around here. So how this while loop would be written would be while this condition is not true, go and do these things. And we'd keep doing these statements as long as this condition was not true. And as soon as this condition became true, we would go on to the next one. This is a typical Sentinel loop. A Sentinel loop is a loop which is controlled by an input from the user. So the user is going to input an amount, which is the current sale amount. That symbol there indicates an input. And so when that input becomes, so the user can get out anytime they want, all they have to do is enter an amount of 0, and then this condition will become true, and we exit, because what they're saying is, sorry, while the current sale is not 0, keep doing this. And so it will become 0, and then we go out. That's a Sentinel loop. This does not show a loop. It shows an input one time. So let's look at it in a loop. I think that's the next one. So yeah, here we go. All right, so this would be an implementation of the flow chart that we looked at, and you see what's happening here. Here we have an input, and this while statement is going to test what is the value of that input. When as long as that value of that input is not 0, then these things will keep on repeating. We'll keep on asking. If you look at these two statements here, they're the same as these two statements there. So all that the user has to do to avoid this loop or to get out of this loop is enter the number 0, and then they'll get out of this loop. This is exactly the flow chart here has been translated into Python code. So we get a value from the user. This other thing just happens with that value. And if that value ever becomes 0, then we get out of the loop. But as long as that value is not 0, then we have to keep on entering. And so that's shown as a while loop here. We get the value from the user. If that value is not 0, we have to go and get the value again. And as soon, but at one point they will stop. Now notice again the indent. So we see these parts of the while statement. We have the condition. Here the condition is shown between brackets. The brackets are optional. Okay, if you were doing pseudocode, you'd have to do the brackets. In Python, you don't need those brackets, but you can put them there. But what is not optional is that colon. You have to have that colon, and then these indents have to be exact. That's why I've been careful in telling you, as we've been having our other lessons, is don't start hitting your space bar and backspaces and stuff like that. When you get to the colon, just enter and it will do the indent for you. If you do happen to backspace, then use backspace and tab, not space, right? Usually this will be one tab. So this being one indent in means that these two statements happen inside the while loop. Whereas we see this print statement afterwards, that means that's happening after the loop. It's not inside the loop. All right, so we've got another diagram here. And again, we have done this before. We did this a couple of weeks ago, and when we did it a couple of weeks ago, we were focusing on the flow charts and the pseudocode. But I did show you a translation of it into Python code because I just wanted to prepare you. But now we're just going over it again, but this time focusing on the Python code. But it's stuff that you've seen before, okay? It's not new, it's not strange. But what we see happening here is we're going to keep doing something a number of times. If we know how many times we're going to do something in a loop, it's common to have a counted loop. And in the counted loop, we set a counter to an initial value. Here, the initial value is 0. And then this green thing here saying increment the counter. What that means is add 1 usually. We add 1 to the counter, and eventually the counter will reach a value which is set in the condition. And so when the counter becomes 10, then we stop. That's how we would do that. So that's a counted loop. A counted loop is different than the Sentinel loop. In the Sentinel loop, we didn't know how many times we were going to do it. We let the user control it because we stopped the loop by something that the user typed. With a counted loop, we know how many times we're going to do it, and we count as many times to do it, and we do it. All right, so you might remember this from like a lecture, I don't know, lecture 3 or something, you know. We wanted to get over the problem of doing this 100 times. So we could have a counted loop that would just print that 100 times. Well, here it is 10 times. And so what we're saying, okay, we have an initial counter, which we set to an initial value, 0. As long as the value is less than 10, we'll keep printing it. And the last thing we do in that while loop is we add 1 to the counter. So the counter will start off as 0, and then it'll become 1, and then it'll become 2, etc. When it becomes 10, we stop. But as long as it's less than 10, we keep doing that. We've done those before too. The average problem, again, I think that we've done this, and we'll do another one today, but the idea of an average problem is you have 2 things that you initialize to 0. You have a total and you have a count. As you go, as you repeat, usually a number of times, you can do it with a Sentinel loop or you could do it with a counted loop, but you get a count and you get a total. You divide the total by the count, and that's your average. And so here in this case, we say, okay, well, how many times we're going to do this? We're going to get 10 numbers. So inside the loop, we got a number, we add it to our total, and then we add 1 to our counter. Eventually, when our counter becomes 10, we can divide the total by 10, and that's our average. That's the average of 10 numbers. So the idea of a nested loop is we have a loop inside a loop. This is going to be a bit fun. I think we need to go and look at this in Python, I think, with some tracing, because what you'll see is is you can do different counters, as it says, with the loop inside and the loop outside. And it's kind of like spinning gears. The inside loop, if you have a loop inside a loop, let's have a look at a loop inside. This is a loop inside a loop. The J is being, what's going to happen here is this is going to happen 3 times. And then this is going to happen 5 times. So actually this thing about J is going to happen 15 times, because we're going to do this once, then we're going to do this 3 times, then we're going to do this again, then we're going to do this 3 times, then we're going to do this again, then we're going to do this 3 times. So every time we go through the outside loop once, we go through the inside loop 3 times. I think the best way to get an idea on that is actually to actually put this into Python and have a look at it. So let's do that, or I'm going to do that. I'm going to get some Python code going with this, a new file, and I'll call this a nested loop. I'll put the code in there, and it won't make much sense to you unless I print everything, right? So what I'm going to do is I'm going to print. Oh, let's put numbers here. So remember, whenever I put a hash in the red stuff, that's a comment. It's not going to be part of the Python program. But what I'm going to do is I'm going to put line numbers so that we can see what's happening here. So this is line 3, and here I'm going to print that so hopefully you can see what this means. This means I'm at line 4. Okay, this is line 4. You agree? Line 1, 2, 3, line 4, and then I'm going to print what is the value of, I guess that's J. So what is the value of J? I'm going to put J's value right there. And so I could just do that with, this probably is the easiest way to do it. We've done it other ways, but okay, so that's going to print out J's value there. And you should see that J's value at line 4, we should print line 4 5 times, right? Because it's going to go 1, 2, 3, 4, 5. Now, what about this? This is going to be line 5, and this is going to be, let's print this with a little bit more information in it. So this is going to be line 6. Agree? You agree with me? This is line 6. We're going to have, what is the value? This is just doing a star. So what I'm going to do to make that a little bit more meaningful is, besides the star, oh, well, that's, yeah, whatever. I'm going to I times J. All right. I'm not sure what, okay, I think what you have to do is do this. But what I'm going to do is I'm going to say, ooh, I want to print I and I want to print J. So I'm going to go back to just put a I here. And what is I? And then I'm going to do a J. So we should see the J. I'm thinking that the J doesn't get, oh, yeah, okay. The I here is, all right. Probably, yeah, okay. So here's line 7. And here's line 8. Should we print these two? I don't know. Let's run this first and see what's going to happen. So I'm going to call this nested loop. I might mess it up because it's supposed to be some special drawing or something, right? So something in here is not working. Maybe it's this here. I don't know why they did that. Yeah, all right. All right. Yeah, that's weird. Because that's a special symbol, right? Yeah, I think it might be better like that. I, J, This is kind of weird. I don't know what they've done with this, the heck with it. Let's do it. Forget about that. So we're going to print out what's I, and we're going to print out what's J. I need to do plus. So that should work better. Sorry about that. They just had some weird stuff in there, all commas and stuff. I mean, it wasn't going to work. Right. So hopefully you can see there the lines of code. We do line 4 once here. Then we do line 6 3 times. Then we do line 4 again, right? Actually, J is getting put back to 1. Then the J becomes 1, 2, 3. Look, I's 1, then I's 2, then I's 3, then I's 4, then I's 5. You see that? So that's the outside loop where I gets changed. Every time we go to line 4, it doesn't show it, the print, but if we look back at our code, so I hope this makes sense. What we see is every time we come here, we set J equal to, J gets set equal to 1 again. So that's why every time we come here, J becomes 1, J becomes 1, J becomes 1. That's happening at line 3. So when we print it at line 4, it's always 1. All right. So probably we should print what's happening with I here too. So let's do that here. Oops. Again, we'll do that. Let's run it again. Yeah. So you can see as we go through, I's 1, J becomes that, right? I changes to 2. I's 1, J's, sorry. Yeah, J's 1. J's 1, I's 1. Then we go into the loop. So here, line 6, this is only happening inside the loop, right? Line 6. And so we see J changing 1, 2, 3. J's changing 1, 2, 3. That's happening here at line 7, right? And then we keep going through here. We don't actually do this line 8 until we finish doing this thing 3 times. We could see that if we put another print here. I'll do that here. I'll take this print just so you can see. But this will be line 4, line 9. And maybe I'll take this print. Yeah, that's fine. Let's run it again. And what you'll see here, well, let's see. So we see line 4, that's this print here, right? That's the outside loop. What I want you to notice, especially and focus on, is that line 4 and line 9, line 4 and line 9, line 9 and line 4, line 9 and line 4, line 9 and line 4. How many times do they happen? They happen 5 times because they're in the outside loop. Both line, so line 8, because line 9 is just printing what's happening in line 8. This is the outside loop. We got that. The inside loop, that's line 6. So line 6 is happening a lot more times. If we counted it up, how many times would it be? Well, it'd be 5 times 3, right? Because here's 3 times and here's a 5 times. So this is what I mean, like it's a little wheel spinning inside a big wheel, right? The inner loop is, look what's how many times we print line 6? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Why 15? Because we go through this, every time we get this loop, we do it 3 times. But how many times are we going to come to that loop? 3 times. Sorry, 5 times. So 3 times 5 is 15. Whereas the outside loop, which includes line 4 and line 9, that only happens 5 times. Does that make sense? Yeah, so that's I think that's a pretty good illustration of those kind of loops. That's kind of it for this lecture, but we've only done 30 minutes. And so what I think we should do is just have a look at the tutorial. Is that okay with you guys? Have a quick look at the tutorial. Other thing is, okay, to make it a little bit sweeter for you, we do the tutorial now. Maybe we have a bit of time at the end of the week where we can sort of relax a bit. Does that sound good? Especially we have the there's a skills test on this week. So let's have a look at the tutorial if I can find it. Tutorial 5. Now you will have seen this kind of stuff before. That's why I gave you the drawing, the what you call it, paper, the trace paper. There's trace paper there, but you'll notice. Oh, read only copy. Why did I do that? Yeah, all right. It's locked by another user. Yeah, okay. Tutorial 5. Just put it on the desktop or something. Just for today, we'll throw it away afterwards so I can edit that. But what I want you to notice is I've given you also in the course, we've got the tracing paper there, so you can download the tracing paper. And you can sort of go ahead and do this. So I know we've done the tracing paper before. Let's see what we got going on in this tutorial. So if we're going to do it in tracing paper, I suppose I should put above that line a row above, and I should let's just let's do the layout. Oh, come on, this is in my way now. It's because I want to do a merge. There we go. So this one is going to be tutorial 5. And let's have a look. So starting straight up, we've got we got some line numbers here. I can see a line number 1. I probably should make this so it's easier to see by centralizing them. So again, it's kind of, there we go. And back to that. Right, so we got line 1. Now, so this is our variable here. The first variable we got is a V. And what happens at line 1 is V takes a value of 23. I hope you'll be all right with that. Then at line 2, we get a new variable, which is X. And X takes the value, V doesn't change, right? And X takes the value of 0. Then we go to line 3. Now we've got a while statement. So I'm going to put the condition of the while statement here, which is, that's V is bigger than 21. So let's see what's happening here. At line, we don't change these values at line 3, but this is either going to be true or it's not, right? Is it true that V is bigger than 21? Well, V is 23, so this is true. So what that means is that we have to go and do lines 4 and 5. If it was false at line 3, we wouldn't do lines 4 and 5, right? Because it's true, we do it. And so that's going to bring me down to line 4 here. That's what it means is I'll go and do line 4. What happens in line 4 is V takes a new value, which is V minus 1. So that's going to be 22. X doesn't change. Then we go to line 5. And at line 5, what happens is X takes a new value, which is X plus 4. So nothing happens to V, but X becomes X plus 4. Well, it was 0, so now it's going to be 4. Now, what do we do after line 5? We don't go to line 6 because we're in a loop. And so what we have to do is we have to go and check the condition again. So we check the condition. That means we go back to line 3. And at line 3, these things do not change. But we're going to see if this is still true or not. And that should be lower. We're going to see if this is still true or not. So is it true? The thing says V is more than 21. Well, it is true because 22 is more than 21. So I can put a true there in that condition. And that means that I go on to line 4. Get the idea? And so at line 4, what happens is V takes a new value, which is its old value minus 1. Well, its old value is 22. So its new value is going to be 21. The value of X doesn't change. But at line 5, the value of X changes. And so, but the value of V, nothing happens to it. So X changes, it takes a value, which is its old value plus 4. So it's going to become 8. And then we have to, because we're in a loop, you see the loop there, right? You can tell by the indents, because this statement is outside the loop. So we have to go and check the condition again. That means we have to go back to line 3 and check the condition. These things don't change in the condition, but what we'll see is this condition still true? Is V bigger than 21? Well, V is 21. So 21 is not bigger than 21. And so I'm going to say false. That's not true anymore. And so that means that as soon as the condition becomes false, we have to leave the loop. We can't stay in the loop. So we're going to go to the next line after the loop. Well, the next line after the loop is just this print statement. So that's going to be line 6. So that's why we skipped from line 3 to line 6, because the condition was false. Now these things don't change. And so in line 6, we're going to print X. So that's going to come as the output. Line 6, output, whatever X is. Well, X is 8, right? It'll print it. That's how that would look. Easy peasy. So that's the first one. That's how I would do it. Okay. Easy peasy. Yeah, Japanesey. So the next one. Oh. We got to and also we can test this in Python, right? We got time to do all that. I'm going to the meeting will end in a bit. So I said, well, we can test it in Python. Let's do that. Take that. You want to do that or just go on to the next trace? We can test it in Python after, right? All right, yeah, let's go on to the next trace. All right, so the next trace, I'm going to merge those cells. And this is, what's this one? Mystery. Okay, so, oops. And so in the next one, mystery. In the next one, the first line, we have a variable called mystery. And mystery takes a value of mystery takes a value of 4 from there, right? Mystery takes a value of 4. Then the second line, we have another variable called other. And mystery doesn't change because we didn't do anything here to change it, but we created a new variable and we gave it a value of 32. So now we've got this condition that goes with a while statement. That's at line 3. So hopefully this makes sense because we've done it before just a minute ago. So same as we did up here, right? So maybe I can join those two, do a merge. There we go, merge. So this is going to be the while statement, which is while what? While mystery is less than 20. That's fine. Now at line 3, we're testing mystery, right? So these values don't change, but we test mystery. It's either true or false. Well, mystery is 4. Is that less than 20? Yes. So this is a true. So that means that we go and we do the loop. The loop is lines 4 and 5. So away we go with that. So that means we do go on to line 4. Line 4, what happens is we're going to print out these things. So the values don't change, but there's something happens over here in the printout, which is, make sure I'm in the right line. That's going to be there. Yeah, that's right. So what's going to happen in the printout? We're going to print the mystery plus a space plus the other. So the mystery is, so what we're going to print is we're going to print, mystery is 4. So we're going to print 4, comma, 32, just like that, because that's what it says to do here in this line. Then what we do in line 5, oh, by the way, you could put this is printed, so it's just printed. So it's going to look like that. This also is just printed. So when we print it, we convert it to a string. So then in line 5, we go and do line 5. Line 5, you guys know what's going to happen here, right? What's the number in line 5? Can you see? Mystery is going to take a new value, which is going to be the old value of mystery multiplied by 2. Very good. Thanks, Shema. It's going to be 8. Nothing's going to happen to other there. But now we have to go after line 5, because that's where the while state, this is all a while statement stuff. So we now have to go back and check again. So we go back to line 3. These things don't change, but we have to check. Is it still true? Well, the question is mystery still less than 20? Yeah, 8 is less than 20. So yeah, I think you can see how this is going to go. We're going to print out on the next line, because the next line we're going to do line 4. These things don't change, but we're going to print out, instead of 432, we're going to print 832, right? Because that's the printout at line 4. Then we multiply mystery by, in the next line, because the next line we go to is line 5. Did line 4, go back and do line 5 again. And mystery gets multiplied by 2, so mystery will be 16, Shema says. And Shema is exactly right. Other doesn't change, but mystery does. And so mystery became 16. Now we have to go back and check again. We have to go back to line 3 and do the check. So the check is asking, is mystery less than 20? Well, yeah, 16 is less than 20. So that's still true. So because it's true, we have to go and do the print again. That's line 4. So what's going to print? What's it going to print here? Instead of this, it's going to print. It's going to print mystery and then other. So it's going to print 16, 32. And then it's going to go and check if it's still true. So that goes back to line 3. These things don't change yet, but they will later. Line 3 is checking the truth. Is the mystery less than 20? Okay. How many times do we have to do this? Quite a few, right? Did I get that right? Did I miss something? It looks like I missed some. Oh, yeah, I missed line 5. Oh, sorry. I knew that looked bad. Okay, so what happens at line 5? Before we go and check, we have to multiply the mystery by 2. So the mystery has to become 16 times 2 is 32. So now we go to line 3. Sorry, because we had to do line 4 and line 5. Line 3, these are both going to be 32. And so what's going to happen there? Is 32 less than 20? No, that's false. So because it's false, it means we can't go and do line 4 and 5 again, because they're controlled by this condition. This condition is no longer true because the mystery is bigger than 20, or it's not less than 20. That's the important thing. So we can't go and do them. So what will we do? The next thing we'll do, go to line. Which line will we do after this, after line 3? Skip lines 4 and 5 and go to 6. Very good. So we're going to go to line 6. Anything going to happen to mystery in line 6? No, nothing in mystery, but other's going to change. So mystery stays the same. What's going to happen to other? Which will be 16. Normally what would happen in Python is it might try and convert that to a float, 16.0. Okay, we could try this program in Python and see what happens. So then we're just going to print it out. So there's no more loop. We go to line 7. And in line 7, these things don't change. They just get printed out. So what happens is it's mystery. Yeah, so it's going to be the same thing, right? Now, actually, if I look at it, it's got a space in there. So I didn't quite print these exactly right because there was spaces in there. So the last one is, it's going to be like that, but it's going to be whatever this value is, 32, comma, space 16. That's what it's going to print. Everybody okay with that? Wasn't that fun? Okay, so you might not believe me. It is true, but you might not believe me. I don't know. Yeah, are we still recording? Yeah, we're still going. So we got two choices here, right? We can go on and do the next solving problems with Python, or we can try and put these things in Python. Volume problem user loop. These are what this is. This loop is the same loop as we've seen in the notes. What it is it's the temperature for the week. So it's a counted loop. We're going to do it 7 times. We read in the value of the temperature, then we take the totals, and then we divide and get the average. Do you want to do this, or do you want to convert the other? Let's do the temperature one. And what the heck? All right. So how we would do that is we need to. So we could call this weekly average temperature. And so what we do with that, because it's an average, it's a counted loop. We know how many times we're going to do it. We're going to do it 7 times. So we need a counter, and we need to set it equal to 0. That's our counter for the loop. We also need a total, and that's got to be equal to 0 as well. Then we can start our loop. It's going to happen 7 times. Then we're going to read our input, which is our temperature. And we could do it as a float, or you could do it as a integer, depending on how you read your temperatures. Do you read them as a whole number, or do you read them as a decimal? Well, let's say you read them as a whole number. That's fine. Then we just do that, and we just let's not make it too much writing or typing. We're just going to ask them for the temp. We're going to take it fairly simple like that. We add the temp to the total. And we add the one to the count. And then we get our average, right? So our average is going to be total divided by the count. Then we can print it out. I think you'll see that the average quite likely could be a float. So that's kind of how that would look. Okay. It wants to show it at the bottom of this. So kill it and run it again. Right. So this should give us exactly 7 temperatures. So, I mean, 45. Oops. What do we got? Count is not defined. I call it count here. I call it counter there. That's not good. Let's just make it the same thing. All right. Newbie mistake. Temp 45. Temp 43. Right. So the average now is 44, right? Let's make it a little, doesn't have to be hot every day. How many times am I going to do this? Because maybe I'm getting tired of doing this. How many times am I going to do this? 7 should be. If it's not 7, then I did it wrong. Did it right. Okay, and so that comes out the average there. That's a counted loop. We did a counted loop because we knew how many times we were going to do it before we did it, right? And so we used a counted loop. So that was easy. That was fun. Well, it was fun for me. I don't know. Was it fun for you guys? So we got our average there. Problem 2, modify the program to work on any number of days. Any number of days? Nice. Okay, so instead of doing it 7 days, what we do is we ask the user how many days. How many days? So, and instead of doing the count less than 7, we say the count less than, come on, help me. What am I going to put here? Guess. I'm asking the user how many times. Basically, what I'm asking the user is, how many times do you want me to do this? And the user says how many times. And so what am I going to do in the loop? I'm going to, instead of having the number 7, I'm going to have the number that they gave me. If they said 5, I'm going to use 5. And so that number will be saved in the variable called days. So now I can just do that. I can say, okay, we're just going to do this however many times you said. And so that will work. That was very easy to change that, right? So let's do that with the number of days. So no longer weekly, is it? It's just however many times they want. Let's run this again. It's no longer weekly. How many days? Well, let's say 3 days. So we get it shorter. So, it's not summer yet. If it doesn't stop now, I did it wrong, but it did. Okay, so it only did it 3 times. Why? Because we asked here, we use this as the thing to stop our loop, right? As long as the count was less than that number, we would do it. So it's only going to do it 3 times this time. If we did it another way, it might do more. And modify a program, keep requesting until all right, so what we would do this time is we would say, goodness gracious, we could ask the user to enter the temperature here. So I'm going to copy that there. So now we're going to make it a Sentinel loop. We're going to ask them for the temperature. We're not going to do this how many days thing. This is the last one, right? And what we're going to do now is this is going to be a Sentinel loop. So the Sentinel loop is they're going to keep doing it until what? Until the temperature is what? Until the user enters a temperature of 100. Okay, so what we're going to say is while temp, instead of count, we're going to say while temp is less than 100. That's our Sentinel loop. So a Sentinel loop is controlled by the user putting an input. The user's putting an input now, that's controls it. So we will stop when they do that. Now, I'm going to take this and remove it from there because we've already got it at the top here, right? So I'm going to remove it from there and I'm going to put it to make it the last thing in our loop. That'll make it better so that when they do the temperature of 100, it doesn't add into our average. So notice the totals. Yeah, anyway, so let's try this one. This is with a Sentinel loop. So I'm going to change that because it's not weekly. It's Sentinel average loop. So let's run that. And as long as the temperature is below 100, it will keep doing it. Notice it's not saying anything, about the totals or anything. I can just keep on doing that. I could put 99, but my gosh, nobody can live at 99. When I put 100, let's say 101, it should stop. Yes, and gives me my average of 37. Now, 37 is the average of these three. It doesn't include the number 101. We don't want it to include the number 101, right? If it did, that would be really bad. So the 101 was that's why I put this input at the end of the loop. So if it becomes 101, it goes up here and checks that. Oh, so we don't add it to the total. That temp doesn't get added to the total. So that's how we do that as a Sentinel loop. Okay, folks, that looks like that's the end of the tutorial. Isn't that fun? All right, so just what we'll do the last little bit is maybe we'll just play with this. If we still got a few minutes left of recording, I'll take that and put it into Python. Let's do the mystery. Let's call this mystery. Oh, mystery. Now, when I copy this in here, problem is it's got all these. That's not going to work very well, right? And likewise. Now it's okay, but the thing is, how do I get my indent right? Well, what I'll do is I'll go right back to there, and I'll hit enter, and it'll get my indent exactly right. Same here, I'll go right back to here, right back to the end of that line, hit enter, and it indents it exactly right. And this one shouldn't be part of the while. And this one shouldn't be part of the while. So what this was supposed to print out was going to be, let's see if it prints out the same as our trace. So let's just call this mystery. Should print out the same as our trace. There we go, 30, 36 and 16. Well, yeah, look at that. Yeah, I said that it might change that 16 to a float, and it did, right? When it does let's do it again. When we did the divide, it changed that number 16 to a float. So I got to change my my trace to reflect that fact, right? It changed that to a float. I should have known that. And I did tell you that I think it might do that, didn't I? And so there it did. It went and did it. It changed it to a float. So this is not like that. This is a float. I got to put that there. That's a float right there. So that had to change to reflect the fact that when we do a divide on two integers, Python converts it to a float. All right, so let's do the last one, which is this, I don't know, V and X. And then okay, so a new file, let's call that V and X. I don't know, for want of a better name. Again, so easy to do that. Just delete all those stuff leading on. Now this we have to get the indent right, so I go up to that. Likewise, got to get the indent right, so I go to the previous line, enter, and Python will get the indent right for me. So what this should print, according to our V and X, is going to print 8. Well, let's see. V and X 8. Ta-da! All right, so I hope that means something to you guys. Do you have any questions? Because if you don't, I'm going to stop the recording at least.